Welcome. This is Coach Dorf. We're in section 2.7, and we're going to look at the following example that's like a homework problem. All right, in this problem, we're given two parts, and in each part, we're supposed to determine a function f and some number a so that what we have in part B, they represent the derivative of that function we find at the point A. So the first thing we should remember is these formulas or definitions for derivatives. So derivatives can be represented as either one, as the limit, as h goes to 0, f of a plus h minus f of a over h, or they could be represented as the limit as x goes to a of f of x minus f of a all over x minus a. All right, so we can look at our two parts here, part A and B, and see which one of them fits into which of these formulas or definitions for the derivatives. So B is the limit as x goes to 2 of x to the fourth minus 16 over x minus 2. So I asked myself, which one of these formulas, one or two, matches what we have for letter B? Well, it's going to be number 2. So this matches the definition in number 2. So this and this match up. Now, how do I see that? Well, the first thing is I could look at what's under the limit sign. All right, for us here, we have the limit as x goes to 2, and here we have x goes to a, and we have x equals 2. In the definition for number 1, it's h going to 0. Well, there's no a in this letter B here. It's x going to 2. So that's a really clear sign. Also, what's in the denominator? The denominator has x minus 2, and this has x minus a. In the first one, we have an h in the bottom. There's no h in the bottom here for part B in the denominator. There's no h. So this really suggests, and it's true, if we want to use definition number 2. So what we need to do is we need to find f of x and a. So I'm just going to compare these two. Compare B with 2. So here's B, the limit as x goes to 2 of x to the fourth minus 16 over x minus 2. And here is 2 is the limit as x goes to a of x minus f of a over x minus a. So first thing I would ask myself is, what is a? It's going to be a number. And if I look at these, really there's some signs that tell me what it is. So first of all, I have x going to 2 on the left here, and on the right one, the formula for number 2 is x is going to a. That suggests that a is going to equal 2. Another hint is that in the denominator on the one on the left, we have x minus 2, and on the right in the denominator we have x minus a. That also suggests that a is 2. That's that works. We're gonna guess what these are using logic. So what we did here, I'm fairly confident that a is equal to 2, but once we figure out what f is, then we'll go back and check it to make sure that it all works. So what is our guess for f of x? Well, I notice in the right-hand side, f of x is listed there on the top, and here I have an x to the fourth. That suggests to me that f of x is going to be x to the fourth. Check that these are correct. That is, suppose f of x equals x to the fourth and a equals 2. Then write out definition 2. Definition 2, I don't like that pink so much, so let's go back to blue. It's the limit as x goes to a of f of x minus f of a over x minus a. All right, so we're going to use f of x and equals x fourth and a equals 2. So substituting those in, I get x going to a, which is 2, and then I have f of x, which is x to the fourth, minus f of a. Whoa, what is f of a? So if f of x is x to the fourth, then a is 2. F of 2 is going to equal 2 to the fourth, which is 16. All right, so then I get minus 16 on the top, and on the bottom I get x minus a, which is 2. Now how does that compare to what the original problem was? Well, if we look at the original problem here, for letter B, it's up here, and we see that they match exactly right. So my answers are, so we are correct that f of x equals x to the fourth and equals 2. Because when we plug them into this definition, we get the exact same thing that is given at the very original part of the problem. What's in the blue box here on the screen matches what's the blue box given in the original statement of the problem. So that was part B. So now let's do part A. All right, and in part A, we have this limit here. I'm going to mark this in green. Okay, we have the limit as h goes to 0 of the tangent of pi over 4 plus h minus 1 over h. So let's see if I can remember that one. So that's the limit as h goes to 0 of the tangent of pi over 4 plus h minus 1 all over h. All right, and we're going to ask ourselves, this is going to be one of the definitions. We have two definitions. Remember, the first one was that, let's write it, let's do it with the limit. So we have the limit as h goes to 0 of f of a plus a minus f of a all over a. And the second one is the limit as x goes to a of f of a, f of x, sorry, minus f of a all over x minus a. So we want to ask ourselves, this green limit we have that was given in the original problem, which one is it? So in green, this is either 1 or number 2. And we look at it, the fact that we have h going to 0 here, and we have an h in the denominator, tells us that this is the formula number 1, the definition number 1. All right, so we're going to use definition 1. So let's rewrite both of these here. Again, I have the limit as h goes to 0 of the tangent pi over 4 plus h minus 1 all over 8. And we have in black, and we have the limit as h goes to 0 of f of a plus a minus f of a all over h. Let me just make sure that that's what I started with. Yep. All right, so now we need to find f of x and a. That's our goal here. All right, so if I look at these, I'm looking here and I see pi over 4 and I see an a there. And so that suggests a equals pi over 4. All right, we're making a guess. We're not for certain that this is what it is, but we're going to make a guess, and then we're going to check it at the end. All right, how about f of x? Well, I have the tangent here, and this is my f here. So this is going to suggest f of x equals tan x. So I need to know that is, so if f of x equals tan x, and we have a equals pi over 4, then I use the definition, number 1, limit as h goes to 0 of f of h minus f of a all over h. What does that equal? I have the limit as h goes to 0. I'm going to put in f of a plus h. That's going to be tan of pi over 4 plus, because I'm putting in, right, that's going to go in there, and I've got tan that goes in there, all right? And then I have f minus f of a, so that's going to be minus the tangent of pi over 4 all over 8. And now, what is the tangent of pi over 4? The tangent of pi over 4 is 1, and so I end up with this, and this matches what we had here, or if you want to think of it this way, in the very original part A, it matches the green one. This matches, and so f of x equals tan x, and a equals pi over 4. Those are my answers. All right, hope that helps.